Hello and welcome everyone. The purpose of this video is to go through common pitfalls on the key assessment Unit 5 Macroscopic Energy Science 10 Physics test. So I'm going to walk through the problems. As I'm doing that, you might have the mark scheme open. A mark scheme identifies exactly what we gave marks for and what we didn't give marks for, and where marks were maybe possible or taken away. So this is a useful document to be looking at as you watch. You might also have your own assessment open to help figure out how your answers matched up with or maybe varied from what we were expecting. All right, let's jump into it. The first thing I want to mention, this is sort of a small thing, but I saw a lot of people not actually signing the academic honor policy. Please make sure you do that. Academic honesty is super important, especially now in distance learning. So we do ask that each time you actually take a moment to read what we're expecting of you and you agree to it. All right. So this is the master copy. Depending on your version, you might have watched one of these videos. They all got at exactly the same ideas. So question 1 asked you to complete the table. The table asked you to talk about 3 different types of energy. One was mechanical energy, one was thermal energy, and one was a different type of energy of your choice. All right. One thing I saw here, I saw some people trying to do all of the energy types, which sometimes got them into a little bit of trouble. Make sure you're reading directions carefully as you're moving towards becoming an IB student. You just won't have the time on the IB to do way more than what they're asking for. So while I loved reading about all of your different energy choices, make sure you're reading the directions. They're asking for A option or one option, completing just this table, so you did not need to add anything else there. All right, so the biggest pitfall I saw, lots of people got this, but a few people missed this. What is mechanical energy? Well, let's take a look at what we did. Unit 5, Day 3, the Conservation of Energy Qualitative Day. Remember, mechanical conservation of energy simply refers to either gravitational potential energy or kinetic energy. It's not these two added or subtracted or anything like that. It's just whenever you have GPE, you have mechanical energy, or whenever you have KE, you have mechanical energy. They're both examples or subtypes, you could say, of mechanical energy. So that was the biggest thing I saw there. Most of you did a great job identifying an example in the video and then describing what you saw. The other thing that I saw a couple people do here was not really paying attention to the directions. Make sure you're following exactly what the directions say. So here, let me move it over a little bit. In this first column, you were describing what you observed in the video. So I was not looking for you to say anything about energy, just what did you see? I saw the screw hit the tire. I saw the ball hit the cup, or whatever it was that you saw. And then here, your question was, how do you know this type of energy is present? So for example, how do you know that you have mechanical energy? Well, you know that you have mechanical energy because you either have gravitational potential, you either have height or you have something moving, which is kinetic. So you're being clear and specific about those explanations. For thermal energy, some people used an example like a candle when something got hot. Other people used an example like friction, which is also thermal energy. Both of those were great examples. For the most part, people did pretty well on this. Just to show you what got marks here, you got 1 mark for identifying the example. So that would be the time in the video and describing what you saw. 1 mark for explaining, so 1 mark for this last explaining column. And for mechanical energy, 1 mark for being explicit that mechanical is gravitational potential energy or kinetic energy, so using one of these terms. For thermal energy, 1 mark for these 2 columns combined, so the time in your description. 1 mark for your example, explained. And for the type that you chose, similarly, 1 mark for the time in video and description all as one thing, and then 1 mark over here for explaining how you knew this type of energy was present, for a total of 7 possible marks. All right. Stop and pause for a moment. Try to figure out if you have any questions on question 1, on where you lost points, and make a note of those questions so you can talk to your teacher about it. Okay, let's go ahead and move on to question 2. Question 2, this was really important. Question 2 asked you about without friction. I saw a couple people get caught up and try to start talking about thermal energy. Well, remember, friction is thermal energy. So we're pretending we have an ideal situation and no friction for the first example. So this was very, very similar to the work we did on this day, Unit 5, Day 4, when we used the FED example. We used our little buddy, the dog, or maybe a person with the skateboard, and we were looking at how energy was transformed and conserved. So you are assuming the ramp is frictionless. What were we looking for here? Well, here we were looking for, excuse me, I'm just trying to clear my, oops, my screen. Okay, sorry about that. Thank you for your patience, sir. All right, what were we looking for here? We were looking for basically walking through exactly what we walked through in class this day. So the first row that you had to fill out corresponded with a situation like this that we saw in case 1 in our classwork. So we have all GPE because the dog has a lot of height, and no kinetic because the dog is not moving. Go ahead, take a look at the mark scheme. Notice that 1 mark required you to say all GPE and no kinetic energy. That was 1 mark. And then the second mark was explanation includes discussion of non-zero height and non-zero velocity. So this was not a half mark situation. You got 1 mark for saying all of this. You have height and you're not moving, just like we did here. We have height and we're not moving. The in-between situation, people did really well with, for the most part. So this was more like case 2. We have, or excuse me, case 3. We have some gravitational potential because the dog has some height. We have some kinetic because the dog is also moving. So all of this was required in order to get your 2 marks, just like we did in class. And then the very bottom of the ramp, well, that was very similar to down here with our little dog. We have no gravitational potential because the dog has no height, all kinetic because the dog is moving. So all of that was required in order to get the mark. So identifying the energy and then the explanation involving height and velocity. A few people mentioned other kinds of energy like sound energy. Certainly correct. We were really prompting you here to set up this problem in the way that we did in class. We mentioned at rest, we mentioned frictionless. So we are really prompting you to think back to Unit 5, Day 4, and the work we did in class, and checking in on how well you understood these case 1, case 2, and case 3 that we worked through together and that you wrote down in the document that day. All right. Explain how energy is conserved. Well, energy being conserved, of course, we're transitioning from gravitational potential to kinetic. They're transforming. So you should mention something about that and mention something about what conservation of energy actually means, what conservation of energy actually means. So you might have said energy cannot be created nor destroyed, or energy has to come from somewhere, energy needs to transfer, total energy is always the same. So we were looking for you to say something like this from Unit 5, Day 4, and to mention that the energy was, in this case, transforming gravitational potential to kinetic. So We see here 1 mark in B, 1 mark for telling us what what conservation of energy actually is, and 1 mark for applying it in this example that we have kinetic energy and gravitational potential. Gravitational potential, of course, decreasing and kinetic increasing as we move down the ramp or whatever object you had in your video. All right, showing on the bar graphs what's going on. Well, that came directly from the work that you should have done on this day in your homework. So you used a lot of these graphs in the document that you did on Unit 5, Day 4. So just reproducing that same kind of graph. Many people did really well here. What we were looking to see was that you did not have any thermal energy because we're assuming no friction, and that kinetic and potential added up to the total. Also that the total did not change before and after. Okay. And then finally, D. So D, you were adding some numbers between gravitational potential, kinetic, and total mechanical energy, just like we did, again, Unit 5, Day 4 with the PhET simulation. So question 2 was really asking you about our content from Unit 5, Day 4, the ideal conservation of energy day. All right, take a moment to pause, ask yourself what questions you have. Make a note of those questions so you can check in with your teacher. And let's move on. Question 3. Question 3, we said, okay, now we do have friction. Now let's think about friction. Thinking about friction, that's what we did on Unit 5, Day 4 when we started talking about work. So question 3 was really getting at the work we did, the work we did together in Unit 5, Day 5. So in A, discuss how your answers to question 2A would or would not change with friction. And remember in 2A, you were talking about types of energy present. You hopefully saw that as the object was moving down, excuse me, let me go up a little bit. As the object was moving down, just like we saw here, you would have friction as you move down a ramp. And so some of the gravitational potential and kinetic energy, goes to friction. We were asking you not about stopping like we saw in class, but we were asking about really this portion here. So some people wanted to show a graph like this on question 3. And the reality is that at the ends of the ramp, you're still moving. At the end of the ramp, you're still moving. And so we were looking for you to see that as you move down the ramp, some of the energy from gravitational potential and from kinetics, some of that energy is getting released as heat, is going into friction. So that transformation you described in question 2 from gravitational potential to kinetic is correct. But when you also consider friction, it's not just GPE to KE. The GPE, some goes to kinetic, but some also goes to friction, which is thermal energy. Thermal energy. All right, so lots of you did a really good job with that. This idea, there were 4 important ideas to include. So first of all, we wanted you to recognize that friction is thermal energy. Just like we saw here, we saw these little heat signs. We talked about how it would get hot. How would you feel if the chalk, with the chalk if you touched it? So we wanted you to recognize that friction is connected to thermal energy. We wanted you to recognize that gravitational potential and or kinetic is transferred to thermal energy instead. So that's a big difference between considering friction and not. We wanted you to, of course, recognize that the total energy would remain the same because the total energy always remains the same. Total energy does not change. So some of the energy is transferring to thermal. That means you have less kinetic than if you consider the ideal situation. We also wanted you, for that fourth point for absolute complete credit, to mention the word work, because that was the word that we emphasized on Unit 5, Day 5, as well as Unit 5, Day 6. So you'll remember in Unit 5, Day 6, we did yet another example with work, and then you had time in your base camps to get any of your questions answered. And we talked about base camp norms, and then you had time to get all of your questions about work answered. So we actually spent 2 days on work. So to get complete credit, you did need to come up with that word that we used, work. Okay. Showing on the bar graphs, the bar graphs before should have looked exactly the same. After should have been some thermal energy. Still kinetic energy because you're still moving at the very bottom of the ramp, but some of the energy went to thermal instead of all GPE to KE. All right, and finally, the last question. There's a very similar question on the review, which is true for all of these, but this one particularly. But let me show you where we talked about it in class. So explain the energy transformations that happened macroscopically. That's what we can see. That's basically what you've been talking about this entire exam, that GPE gets transformed into kinetic energy, gets transformed also into thermal energy. Thermal energy, that's interesting. I feel like we talked about thermal energy last semester. We did. So thermal energy, we know what happens with thermal energy microscopically. And we even reminded you about that in this warm-up on Unit 5, Day 4. We reminded you all about thermal energy. So the microscopic energy transformations that are taking place, well, as you get more thermal energy, you also get individual particles or molecules and atoms speeding up. So that's what's happening microscopically. When you have friction, you have thermal energy. Thermal energy, as thermal energy increases, the speed of your particles also increases. I did see someone here try to say that particles start moving. Remember, particles are always moving, but as you get hotter, particles move faster, just like we talked about last semester. What's the connection between the macroscopic and microscopic energy? Well, notice thermal energy, it's actually looking at microscopically kinetic energy. Oops, my box got a little weird there. Sorry about that. So the connection between thermal energy, the microscopic thermal energy, and the macroscopic energies is that microscopically, we're actually looking at the kinetic energy of the particles. So 3 marks here, 1 mark for macroscopic, GPE transferred to KE and thermal, kind of saying what you've said before, and recognizing that this is a macroscopic energy transformation. 1 mark for mentioning that thermal means more movement in particles or molecules and atoms. And then this final mark, this is one of those points that really distinguishes a 7 from other grades. We did have it briefly on a slide, but of course, maybe didn't emphasize this point, that the microscopic motion of particles is connected to macroscopic temperature measurement. And it's connected, of course, because it's microscopic motion or microscopic kinetic energy. All right, again, take a moment, figure out what questions you have. And now that you've watched this video, go ahead, complete your reflection. And then at that point, you are welcome to meet with your teacher and chat about your assessment. All right, everyone. Thank you for watching. Thank you for indulging my love of emojis. Have a wonderful day.